Good afternoon, everyone. Myself, Dr. B.M. Patil, Assistant Professor at the Institute of Science, Mumbai. Now I discuss here van der Waals forces. Then, question arises: what is the van der Waals forces? You know that molecules are always attract to each other as well as the repulse to each other, and there is a intermolecular forces of the attraction as well as the repulsion between the molecule. Maybe that molecules are the polar one, or maybe that molecules are the non-polar one, or maybe that molecules are polar and non-polar, and also that is the ions. And there is the attractive and the repulsive forces. Some of that attractive and repulsion forces, repulsive intermolecular forces particularly, is known as the van der Waals forces. Then, types of the van der Waals forces. Here I discuss the three types of the van der Waals forces. First one, dipole forces. Second one, ion dipole forces. And third one, London forces. Then, first one, dipole forces. Particularly, dipole forces will be operative between the polar molecule. And which are the polar molecule? Which have a permanent dipole moment. Those molecules which have a permanent dipole moment, that molecules show dipole-dipole interaction. Then, dipole-dipole interaction will be exist between the positive pole of one dipole and negative pole of the another dipole of the another polar molecules. Then here you see that dipole-dipole forces have how much that is a strength or how much energy will be revolved. That is approximately 5 kilojoule to 20 kilojoule per mole energy will be revolved. Then these forces, dipole-dipole forces, are comparatively that is a weaker as compared to that is the ionic, covalent or the hydrogen bonding. Then these dipole molecules are in a two types. One is head to tail and second is anti-parallel arrangement. You see that is in anti-parallel arrangement is positive pole of the one dipole is interact with negative pole of the another, but in the anti-parallel manner. And second one, head to tail is positive pole of the one dipole is interact with negative pole of the dipole in a that is head to tail manner. Then energy of such interaction can be calculated by using the formula E is equal to minus 2 mu 1 mu 2 divided by 4 pi r cube epsilon 0, where mu1 and mu2 are the dipole moments of the two polar molecule. Maybe that polar molecule is the same substance, then value of the mu1 and the mu2 becomes the same. Then next that is the interactions are ion dipole interaction. Then where the ion dipole interaction will be exist is always ion dipole interaction will be exist between the ions and the polar molecule in the liquid or in the solid state. Then that you know that how the calculate the dipole moment is always equal to mu is equal to q into r dash. Here mu is the dipole moment of the polar molecule, q is the charge on the that poles, and r dash is the distance between the two poles. Then here I taken the ion dipole interaction. Z plus is the one of the ion, q minus and q plus are the polar molecule, and the distance between the center of the Z plus and the center of the polar molecule is dipoles are represented by the r. And therefore, potential energy of ion dipole interaction may be expressed as E is equal to mode of Z plus minus mu divided by 4 pi r raised to 2 r square epsilon 0, where Z plus Z minus is charge on the ions and r is the distance between the ions and the molecular dipoles. Then here I taken the example hydration of the salt. If you take the NaCl in water and stir it, then NaCl will be dissociated into Na plus ions and the Cl minus ion. Then Na plus ions are surrounded by the water molecule as well as the Cl minus ions are also surrounded by the water molecule. Then how that Na plus ions are surrounded by the water molecule? You know that on the sodium, that is a positive charge is there. And in water, yes, negative charge on the oxygen and positive charge on the hydrogen. According to the definition, here the positive charge of the ion is interact sodium ions is interact with negatively charged pole of the water molecule, that is oxygen, and therefore Na plus ions are surrounded by the water molecule by the interaction of the ions, that is Na plus, and the oxygen atoms of the water molecule. Similarly, Cl minus ions are surrounded by the water molecule. You know that on the Cl, that is a negative charge, then positive pole of the water molecule means hydrogen atoms of the water molecule interact with the Cl minus ions, and that Cl minus ions are surrounded by that water molecule, and that interactions are known as the ion dipole interaction. Then ion dipole interactions is depends upon which factors. First one, charge on the ions. If the charge on the ions is a maximum, then the force of interaction between ions and the dipoles is a more. Then size of the ion. If the size of the ions is a small, then the interaction between the ions and the dipole polar molecules is a more. Then third point is the dipole moment of the polar molecule. Suppose if the dipole moment of the polar molecule is more, then that will be more attracted with, that is the positively or the negatively charged ions, and therefore higher the dipole moment, higher is the strength of the ion dipole interaction. Okay, thank you for attending that video lecture. Please, if you like the videos, then subscribe. Thank you very much.